And maybe he dropped off. Well, I can say something about Zachary. Zachary is a student at Orion Academy in California who's a partner of the N3 program, and he participated in a rocketry curriculum, kind of a test run at his high school, and showed a lot of interest in that. So we paired him up with Tony as a mentor to kind of work on a much larger, much more complex rocket project this summer. So he's going to tell you all about it, with a little teaser for what's to come later in August. So Zachary, I'll hand it over to you.
Okay, hold on. Let's see if this works.
Tony's back. Tony, I went ahead and introduced Zachary on your behalf because we're really losing you.
You can try again if you want.
Hold on, I don't know if I can share my screen. I might not be able to on this computer.
Are your slides in Google Slides?
Yeah.
Do you want to send me a link and I'll share them for you?
Hold on. Okay.
Does Tony want to try to talk again while we're dealing with the slides?
I have them ready.
I couldn't really hear.
I think.
Sure.
Oh,
can you hear me?
Kinda.
Then you're gone again.
Yeah.
I don't think it's gonna work.
I think we let Zachary go for it.
Okay. If you,
Poor Tony.
I'll just tell you when to go to the next slide.
Sounds good.
Okay. Let me get my notes. Hi, I'm Zachary Goren, and my mentor is Tony. And today I'll be discussing how I designed, built, and then I will fly my high power rocket. Okay, can go to the next one. Okay, so what is a high power rocket? A high power rocket is like a model rocket, but it's much larger, uses much more powerful motors, and it's made of more advanced materials and generally just overall more complex. So a big difference, as I said, materials. Sometimes fiberglass is used, as when you're going past the speed of sound, cardboard might not hold up. It's regulated by the National Association of Rocketry and Tripoli, which are both rocketry clubs, and then the Federal Aviation Administration governs all the flight areas, where you can and can't fly, that sort of thing. Okay, you can go to the next one. So my rocket, it's technically a level 2 rocket. I decided to include a camera on the side. We're going to be doing 2 flights, each with a J-class motor. It's 3 inches in diameter and 54 inches long. You can move on. So it's got a lot of parts, and I'll go through each one and discuss how we built it. We've got the body tube and the nose cone, the motor adapter, fins, the electronics bay, the parachute and recovery system, and then the camera. Okay, you can move on. So the body tube is made up around 8 layers of fiberglass. So the way we made it, Tony made a mount, just a cylindrical mount, and we put a layer of fiberglass on, and then you put epoxy, and then you put the next layer of fiberglass on, and you just continue to wrap it around. And the more layers, the stronger it gets. We used a 2-part epoxy, and the body tube is, as I said, 3 inches in diameter and then 3.3 inches long. And we also put the NASA logo and the N3 logo underneath one of the layers of fiberglass. Okay, you can move on. So the nose cone was made in a similar way. So Tony made 2 molds, and we layered fiberglass on each side of the mold, with some sticking out on one of the sides. Then when we put the molds together, the fiberglass overlapped on one of the sides, and then we could put epoxy there and it bond. And so then we took the mold off, sanded it down, cut the rough end off, and it was ready to go. You can move on. So the motors we're going to be using are 54 millimeters in diameter. And if we had to use a motor that'd fill the body tube, it'd just be way too big and way too powerful. So we made a motor mount. It's a tube of cardboard with plywood rings at the top and the bottom. And that way it fits nicely into the body tube. We used glue to stick it on. And then it also does the job of preventing the motor from flying or falling out of the rocket. And there's also some styrofoam there, and I'll get to that in a little bit. You can move on. So the fins. Fins are extremely important because to make sure the rocket's stable, the center of pressure or the center of area has to be behind the center of gravity. So you use fins to make sure that the center of pressure is all the way at the bottom, or not near the center of gravity. And so what Tony did, he cut 4 slits in the body tube, and then that was also cut into the styrofoam. And the reason why the styrofoam's there is since there's these 4 holes, the body tube isn't as strong at the bottom. So the styrofoam can hold the weight of the rocket, even though there's holes in it. And so we used an epoxy called Rocca for putting the fins on. And then you might notice that white glue in between the fins and the tape, and that's rocket epoxy. And we made the fillet with that. That's just to make it a little more aerodynamic. You can move on. So then the parachute, I believe the parachute's a pentagon. So we folded it in just such a way that all the corners we can mark all the corners, and then we cut it with a soldering iron to avoid fraying the edges. And then each end has fishing wire that's attached to the parachute itself with glue. And then that's attached to the shock cord, and you can move on. So here's the recovery system. So when you have a high power rocket, you have to make sure it gets back to the ground safely. So that's almost always done with a parachute. And but the problem with our rocket is that it's going to go about 1 mile high. And so if the parachute deploys right all the way at the top at apogee, when it's safest to deploy, it will fall. I mean, it'll fall slowly, and then also it could drift a long ways away, and then it'd be harder to find and then recover. So our rocket uses a 2-part deployment system, or first an ejection charge, a little piece of black powder pops off the nose cone, and then the rocket just tumbles in 2 parts. And then inside the body tube is this pant leg, and that has the parachute itself. And there's a pair of wire cutters, or see how the pant leg is wrapped at one of the ends? That prevents the parachute from just falling out. So the wire cutters will cut that at a certain altitude, and the parachute deploys later while it's falling. And so if you look at the cord itself, the shock cord will absorb the shock when the parachute deploys. The yellow part is Kevlar, so it's very strong and also fire resistant. And then the white is nylon, which is not as strong, not fire resistant, but it is stringy. So it can absorb the shock. You can move on. And then the electronics. So we have a barometric altimeter and an accelerometer altimeter. And we have 2 altimeters for redundancy. So barometric altimeters, they sometimes malfunction when going past the speed of sound, and accelerometers might not be perfectly accurate. So having to make sure that the parachute deploys at the exact right time, or that the rocket separates at the exact right time, because if it separates at the wrong time, the rocket could either just fall to the ground and then crash, or the shock cord could rip a hole in the body tube. And there's also a GPS. You can move on. So the camera, it's just a little GoPro-like camera, and we had to make a sheath for it, or a little aerodynamic cover. And we did that. We just put the camera in a bag, and then Tony made a little wedge. And so we put a piece of plastic on the body tube, and then just layered the fiberglass on top and made it like that. And so when it was done, we took the plastic off and then popped the little sheath out, and that was it. You can move on now. So motors, this is probably the most important part. Every motor has a code, which once you understand what every letter means, it's pretty simple. So the first letter is the newtons, or the total impulse in Newton seconds, and then the first number is the average thrust, and the second number is the ejection charge delay. So as I mentioned earlier, there's a charge that blows the parachute off. That can either be controlled with a altimeter, or some motors have here, I'll show, or can you move on to the next slide, please? So if you look at the right picture, that's a cutout of a motor. Those green parts, those are the fuel grains. That's the fuel itself. And then at the very top, that little gray square, that's the delay grain, which takes a very long time to burn. It could be like 10 seconds, 14 seconds, and then that'll burn through. As the motor burns, that'll also burn through and then ignite some black powder, and that can blow the parachute off too. And at the bottom is the nozzle. And then on the left, these are some reusable motor casings. You can put the fuel in and use them pretty much as many times as you want. Can you move on, please? And then the resources I used RockSim, which was a simulation program specifically designed for high power rockets. You can design it any size, shape you want, and then load different motors and see what'll happen. And also the book, Modern High Power Rocketry 2. And also Tony's vast wealth of knowledge was extremely helpful. He knew pretty much everything we needed to do. I couldn't have done it without him. You can move on. So does anyone have any questions?
Well, we're certainly looking forward to seeing the launch. Do you know where you're going to go launching?
We are launching in Fresno on the 19th.
Of August.
Yes.
Okay, yeah, with the AAA Central Coast Club. Yes, I've gone down and launched with them as well. And Tony, as some of you may have heard, was my rocket mentor as well. So I'm sure that you really learned a lot working with him, because I sure did.
Yeah, I really liked building the rocket. It was very fun.
I was wondering what your favorite component to build or learn about was, because there are all those various components. Did you have a favorite or a least favorite?
I think so. There are a bunch of little things which I didn't talk about. One thing that was really annoying that I did not like, which we actually did pretty recently. So here, I have the rocket right here, actually. Here is the where the camera goes, and then you can see these screws that go into the body tube. But then we have the shock cord inside here, and so we have to make sure the shock cord doesn't get stuck on the screws. So we had to use a stick to lower this little mold inside to put on one of the screws, and we tried for like 30 minutes, and I think we finally got it. And even now it's not perfect, so I guess there could be a chance the shock cord gets stuck on that screw on the inside. But like building the body tube itself was really interesting, and just laying down the fiberglass.
I imagine thinking about all the ways that this launch might not work is also not super fun.
Yeah.
Oh, the launch is only half of it. It's getting it back again. That's the other half. And personally, I always have more problems with parachutes not coming out right and things getting stuck, and then things entering ballistic and becoming lawn darts, but yeah, hopefully it will go more smoothly with you.
I hope so.
Any other questions for Zachary?
You think you'll continue doing rocketry after this project is over?
I'm not sure. I don't think so. Maybe if I have the time, but we'll see.
Oh, when you get to college, maybe you can join the rocketry club.
Yeah.
Sabina's asking in the chat if you shot off model rockets. I know you did during school last year.
Yeah, so my school had a summer camp that was with the N3 program. We built model rockets which were about like only a foot high or 1.5 feet tall, much smaller. And we launched those, and there were like, I think 5 of us or like 10 of us, something like that. It was a nice introduction.
Yeah, and those rising data rockets use E-motors, so they're model rockets because it's less than H. All the way up to G is a model rocket. You get to H, you get to high power. So it's quite exciting. I love it personally.
Well,
I wish you well at the launch. I wish I could go to Fresno and join you, but I don't think I'll be able to do that.
Oh, thank you.
Anyway, let's all give Zachary a round of applause because I think we missed that part. We were
Make
so
lots of
enthralled
photos and
looking at the rocket.
take a video of your launch. That'd be cool.
Yes, definitely please video it and then we'll add that to the website as well.
Awesome.
Anyway, great job. It looks like you had lots of fun.